Hello everyone, in this video I am going to walk you through the first phase demo for an efficient implementation of blockchain based management of video surveillance systems. So basically in this video these are the things that I am going to walk you guys through. So let's start off with the introduction. So in the introduction, so basically you guys will have to understand two things in our project. So what exactly mean by blockchain and what do you mean by video surveillance. So in this introduction slide I'm going to give you an overall picture of what actually we are implementing in our project, and then in the rest of the slides we are going to formally put aside those things. Okay, so let's get started with the first term here, which is blockchain. So the blockchain, as the name itself indicates, it's the chain of multiple blocks. Okay, it's a kind of new data structure that you can think of at this moment. So later on when you attend the formal classes you will be getting a more detailed explanation on that. So but for now you can think of blockchain as a data structure where you will be having multiple blocks connected to each other. Okay, so as shown here, so the blockchain is connected to block 2 and block 2 is connected to block 3 and 3 is connected to 4 and so on. So what actually will be having in each block? Okay, so in each block you will be having three things. Okay, you'll be having something called data, and you will be having something called hash code for the data, and you will be having something called hash code of the previous block's data. Okay, so to be more clear, so let me just tell you what those things are for. Okay, so the first one is data. So this is the actual data which needs to be secured. Okay, so the reason why we store the data on blockchain is to make it secured. Okay, so what data we are securing? So that data we need to store here. Okay, and this data can be of any format. Say it can be a text data, or it can be an image data, or it can be an audio data, or it can be any form of data that we can store in the first field here, the data field. Okay, and the second field over there is the hash code of the data. Okay, so hash code is nothing but a unique representation for the data that we have stored in the block. Okay, so for example, if the data we have stored is hello, okay, assume that the data we are storing is hello, and the equivalent hash code for that may be something like this. Okay, you will be having an equivalent representation for the data that we are storing. So that's what we call hash code. Okay, so the algorithm that we are going to use for computing the hash code so will be MD5. Okay, so we are going to make use of message digest 5 algorithm to calculate the hash code of that particular data. Okay, so the speciality of this particular algorithm is it's an one-way algorithm. Okay, so that means so you can convert a data into the hash code, but you cannot convert the hash code back into the data. So that means you cannot find out for which data this hash code represents to. Okay, and the second speciality of this algorithm is that so if there's a small change in the data, right, so for example someone corrupted this data for small e, he replaced with capital E, so then the hash code changes. Okay, so maybe the hash code for this now becomes something like this, so like that. So any small change that we do in the data, it will result in the change in the hash code also. Okay, so that is why the blockchain is secured. Okay, so in the process called blockchain validation we can figure it out, okay, whether the data and the hash code are matching or not. If anybody who makes a change to the data, I mean if any corruption have been done in the data, its hash code validation will be failing. Okay, so that's how we figure out if the block is valid or not. Okay, so that's the field data, you know what it is, and the hash code of the data, you know what it is, and the previous hash code of the data, previous hash code of the previous data. Okay, so this is the first data, right? So you don't have any other preceding, I mean any other previous data, so that means this field will be stored as null. Okay, so whereas you know, so here the hash code of the data will be stored. something like this. Okay, and here the actual data will be stored, something like this. Okay, so this is what we will be having in block 1. Okay, so now in block 2, so maybe the another data will be stored, like morning and hash code of that particular data, something like this. And the previous hash code is this one, right? So that will be stored here. Okay, so that's how the link will be established. Okay, and the block continues. Okay, so just remember this one part. So any small change to the data like this, okay, this hash code also will be changing significantly like this. Okay, so that's how we determine whether the changes have been done to the data or not. Okay, so this is how the blockchain works in an eye level. Okay, so but in a more detailed way we are going to do that in the class. Okay, and the one more importance of blockchain technology is, so this entire blockchain will not be stored in a single server. Instead it works as a decentralized way. Okay, that means we'll be having some numerous nodes. Nodes is nothing but a machine. Either it could be your local machine or it could be your cloud machine, anything. Okay, so this entire blockchain, for example in our case we have 4 blocks, right? Okay, so 4 blocks will be stored in each of these machines. Okay, we call those machines as nodes. Okay, so right now we have 5 nodes. In these 5 nodes, each of the 5 nodes will be having this blockchain in it. Okay, so something like this. Each node will be having its own so the blockchain data. So it will be like block 2 and block 3, like that. Okay, small correction. Okay, so now you can think from the hacker perspective. Okay, so if somebody wants to hack this particular data, that means if somebody wants to change this data morning to evening, okay, so what will be his effort? So if you, first of all, this is not possible, because if the data gets changed, the hash code also will be changing, and we will figure out that this block is corrupted. Okay, so but somehow if he manages to hack it, say for example he manages to hack this particular block, he will be managing to hack it. Okay, so in this case, okay, now this node will be compromised. It will be like this particular node is compromised, right? So now it is like 4 other nodes are giving different data, whereas one node is giving different data. Okay, so that means 4 nodes and 1 nodes. Okay, so 4 nodes are giving different data and 1 node is giving different data. So that means 75% of the nodes are giving same data. So we are going to completely eliminate this. Okay, we are going to remove this node, saying that this node is corrupted. Okay, so now assume that the user have hacked another node. Okay, so in this case 3 nodes will be giving some data and 2 nodes will be giving a different data. So in this case it will be like 60% of the nodes are giving us the right data, whereas 40% of the nodes are giving us the wrong data. Okay, so still we are going to trust the 60% of the nodes. So that means these 3 nodes we are going to trust it, saying that we have the correct data. Okay, whereas these 2 nodes will be ignored. Okay, likewise if the hacker wants to hack our data, he will have to hack at least 51% of the nodes, which is in practical impossible. Okay, so because the first step here itself, it's impossible to make the changes to the node and change the block hash code accordingly. That's itself is impossible. Okay, so on top of that, compromising 51% of the nodes is really impossible. Okay, so that's how we prove that the blockchain is more secured. Okay, so blockchain is one of the network data structure which can be used for securing the data. Okay, so these are the things that you need to know about the blockchain. Okay, And the second thing that you need to know about is the surveillance. Okay, so you know the concept of surveillance, right? We will be having the surveillance cameras, what we call in simple as CC camera. We will be having them in hospitals, railway stations, bus stations, offices, colleges, temples, in your homes. So everywhere we will be having the surveillance cameras. Okay, so the problem here is, so we will be having a surveillance camera footage, right? So camera footage, these CC camera footage happens to be at most important for investigation. Maybe some crime has happened in an hospital or some, you know, railway station or even some temples, schools, like that. So if somebody wants to investigate what is happening in that duration of time using the CC camera footage, he needs the genuine footage. Okay, so but nowadays the technologies are advanced, so people edit the CC camera footage and, you know, make the video as per their comfortable. And also in some cases people complain CC camera was not working from at the duration where the crime has happened. Okay, so there are a lot of, you know, cheating things that's going on there. Okay, so that's the problem we are trying to solve here. Okay, so how actually this problem we are solving, you know, so this CC camera footage, okay, we are going to store it in a blockchain network. I told you in the blockchain you can also store an image in the data field. An image you can store in a data field like this: image 1, image 2 and image 3, something like that, right? So because video is nothing but a series of images, right? So the CC camera footage, okay, so we are going to divide the video into small images, and those images we are going to store it in a blockchain network. Okay, so the advantage of storing those images in the blockchain network is nobody can edit it, I mean nobody can modify it, and nobody can delete it. Okay, so this is the major advantage that we are getting in blockchain. Okay, modifying the video cannot be done. Okay, if we store those videos in the blockchain, modification is not allowed. Okay, deleting that video is not allowed. Okay, so we can only provide the read access. Okay, so only the read access will be provided to those CC camera footage, but you know, the modification and deletion will not at all be provided, and that too the read access will be provided only for authorized users. Okay, so that's the advantage we are going to get in using blockchain network. Okay, so we get the CC camera footage, divide that into multiple videos, multiple images, store those images in blockchain network. So the advantage of doing this is nobody can modify those footage, nobody can delete the footage, and you know, so whoever have access, they can simply view it, read only access. Okay, it's not a read write access, it's going to be only read only access. Okay, so that's the advantage of your particular project, and the project you are going to do in this you know, topic. So it will be like the blockchain implementation you people will be doing in one shot, and this implementation will be reused by any of the organization. Okay, like the existing hospitals, existing railway stations, existing offices, homes, colleges, temples, all those people can readily use your blockchain data for storing their video frames, so that it will be secured forever. Okay, it's like your project will be easily reusable by the existing customers. Okay, so now you got a pretty good introduction about your project, and you know what exactly we are going to do in our project. Okay, so now let us, you know, formally put forward so the other items in our, you know, the PPT. So now let us come to the objective parts of our project. Okay, so objective actually indicates what exactly we are aiming to do in our project. Okay, so the first objective in our project is to develop a distributed ledger network where each node will have provide the blockchain service to read and write the data. So that means, so the network you people have seen here. Okay, so this is called distributed ledger network. Okay, we call it as distributed ledger network because the data is distributed among multiple nodes, right? And each node will be providing the access to read the blockchain data and also to create a new block. The existing block cannot be deleted or modified, but we can create a new block, right? So that should be the first objective in our project. Okay, and the second objective is to develop a surveillance system to capture the video frames. Obviously this part. Okay, this is the second objective. So we need to implement a model, okay, so which will capture the videos, and that videos should be later on given to this blockchain network. Okay, so that's the second objective. And the third objective is to integrate both of them. Okay, that means the videos recorded by the surveillance module, I mean in the second objective, it should now be given to the distributed ledger network. Okay, so that integration is the third objective. And once it's done, no, so the last one is to provide a read only access on the video frames. So I told you the data stored in the blockchain network cannot be deleted or cannot be modified, but only can be read by the authorized users. So that reading access should be implemented. Okay, so that's our fourth objective, and that's what we are going to do in our project. Okay, so now let's come to the motivation of the project. So what motivated us to select this particular project? Number one, so the blockchain and the Bitcoin topic, okay, people would have heard about it. It's currently an hot topic, right? So the trend, okay, so and the forecast for the next few years, so the blockchain is having a good scope, right? So that's the first motivation for us. And the second thing is blockchain has been significantly accepted worldwide as a secured way for storing the data. Again, no other technologies will provide such a security which blockchain provides us. And the third motivation is, as obviously it can provide a platform for various applications in different areas. That means we are using the blockchain network for storing the surveillance video. Like that, any other data that needs to be secured, so can simply make use of blockchain. Okay, it could be a blockchain based election system, okay, where the user voting process will be stored in the blockchain, and it could be the other information can be stored in the blockchain. So like that, different areas have different applications, and for all those areas blockchain can be used, right? And the fourth thing is it can provide a secure authorization service. As I told you, the data stored in blockchain can be read only by the authorized users, so that part will be well implemented in blockchain. That's our motivation. Okay, so now coming to the problem definition, the formal statement for problem definition. So you can just read it out. So the videos stored in the surveillance system must be managed safely, right? Obviously, but the videos are leaked out to unauthorized persons or viewed, resulting in the infringement of personal information. So that's what happening in the current world without that much security, right? So to solve this problem, a system, many systems have been already developed. So, but still the inefficient research is not, insufficient research to prevent unauthorized leakage by internal administrator. So that means any of the existing systems that are available till now are not sufficient. Okay, so they don't prove that the videos are secured forever, right? So that's the problem definition that we are trying to solve. Okay, so let us come to the literature survey part of it. So literature survey actually explains the reference papers along with some brief working on it and the drawbacks of that paper. Okay, it's a kind of existing system, right? So the first paper that we are going to talk about is Unlocking Digital Cryptography by Digital Cryptocurrencies by Andreas. Okay, so this particular paper provides a cryptocurrency based solution for that video surveillance issue. But unfortunately, it doesn't talk anything about video frames. Okay, it talks about a textual data and other data, but nothing about video frames. That means this solution cannot be applied for video frames, right? And the second paper is an overview for blockchain technology, architecture, consensus, and future trends. So this was being proposed by Zeng Zibin in 2017. and this also works on cryptocurrency, but we have also integrated big data environment on it. Okay, so but still this particular author talks about a textual data, but it doesn't talk anything on securing the video streams, which is not possible in this approach. The third paper that we are talking about is the effects of merging proactive CCTV monitoring with directed police patrol. Okay, so this was being proposed by Paiza Eric in 2015. So but the drawback of this particular approach is, so the internally the video can be leaked. As I told you, the data will be secured, okay, but the owners of the that particular data, right, we call it as an internal leakage. Okay, so that will be a problem in this particular work, and moreover this work is done by centralized fashion. Okay, so centralized fashion means the entire data will be stored in one machine, okay, which is not a good way of storing the data, but in our system it's like distributed, whereas the IEEE author that we are speaking about talks about a centralized fashion, okay, which is a old way of storing the data, and it is not that secured. Okay, the same thing with the the fourth paper also, titled Study of the Ubiquitous Ogg Form System Using Wireless Sensor Network. So but still the video leak issues will be found here, because this author also talks about a centralized fashion of storing the data. Okay, so that's about the literature review. So now let us come to the issues and challenges that we may face in our system, which we need to overcome it. Okay, so the first issue is the blockchain node setup. Okay, so that means, as I told you, so blockchain, more the number of nodes, like this, more the number of nodes, better the security, right? So because if there is only 2 nodes, if the hacker compromises one of the node, then the entire system will be down. But if there are 10 nodes, the hacker should compromise at least 6 nodes. Like that, more the number of nodes, more the security. Okay, so that's the first challenge we have, that we will have to overcome. And the second thing is the validation process. Okay, we need to implement a blockchain validation process in such a way that any change to the data, okay, so the checksum validation will should automatically fail, and it should inform that the blockchain has been corrupted. Okay, so that's second challenge we need to overcome. And the third challenge is resolution to video frames internal leakage issue, because most of the existing system have that problem, right? Video leakage will be internally hacked. Okay, so that problem we will have to solve it. Okay, so these are the 3 major challenges that we will have to overcome in our project. Now coming to the methodology. So methodology just explains what are the step-by-step implementation that we are going to do. Okay, so the first thing what we will do is, we will develop a server-side application using Java and J2EE. Okay, so this server-side application will contain the client layer, web layer, business logic layer, and the database layer. Okay, so this application is basically used for the end users, okay, for creating an account, logging into their account, and starting the surveillance process and viewing the CCTV, for getting the read access of the data from the blockchain. So because we need to provide a read-only access to the the blockchain network, right? So that will be done using this particular thing. And the second thing is, we will implement a standalone component, once again using Java and J2EE, for capturing the video frames. Okay, so we need to read the video frames, and we need to store it, right? So storing part will come later, but first of all we need to capture that CC camera video frames. For that also we will be requiring some Java component, and that's what we are going to do it here in the second methodology. And in the third methodology, we are going to implement a web services using REST APIs. Okay, so web services using REST APIs. So that will upload the videos that we captured here into the blockchain network. Okay, so the video capturing will be done in the second methodology, but that video capturing should be uploaded to the blockchain, right? So for that purpose we need to implement a web service. Okay, that is what we are going to do in the third methodology. And in the fourth and the final methodology, we are going to implement another web service, okay, for providing a read-only access. And this web service will be consumed, will be used by our first methodology, because here is where the end user is providing the credentials, right? After providing the credentials, this methodology, this module will communicate with the web services provided in this module to download that video and show it to the users. Okay, so that's how the project will be implemented. And finally, the references, these are the papers that we are going to refer, which might help us during our implementation part. Yeah, thank you so much.